Hello everyone and welcome to this video. I will talk about this amplifier I received, another amplifier to repair. It's Gemini x02, but the same problem also I found here applies also to the Gemini x3 and x4. They have all the same issues. So the problem of this amplifier is within the power supply section. The 12 volts that are used to supply the operational amplifiers. So let's remember the symbol of op-amp, that this is the symbol of operational amplifier. It takes two different voltages as input for power supply, plus 12 volts and minus 12 volts, two inputs, the negative and positive input, and it gives an output, which is the signal that is amplified from the input that reaches the output. So the problem in this circuit is that the power supply of the operational amplifier is not symmetric, so it received 10 volts on the positive rail and minus 12 on the negative, so this caused clipping and distortion on the output, and this is not very ideal. I'm sorry for my drawing skills. And after analyzing the circuit, I found the issue, accidentally I guess. So first of all, here the B point is the 60 volts that comes from the capacitors. And these 60 volts just flow through the resistor, 2.2K resistor. This is just the usual Zener diode voltage stabilizer. So from this point to the other point there are 22 volts, and here we have another Zener diode, a 12 volt Zener diode. So it means that right here in this point we'll have 12 volts, and in this part right here, yes, this one, we have 12 plus 22, so 34 volts. So this means that potential difference from here to there is 22 volts, and the fan receives 22 volts. This is a very normal 24 volts fan. So it means that the internal resistance of the fan is around 184 ohms. So the circuit should work on idle, but the circuit isn't working on idle actually, because here in this part right here, the 12 volts are also used to supply a relay, and the internal resistance of the relay is 120. And here on the left, the simulator, I reproduced the base circuit. So we have the power supply that goes to the operational amplifier is 12.6 volts, as you can see in the simulation. The problem is that this circuit uses the fan as a resistor. In fact, the current that goes through the resistor is used to supply the second part of the circuit. This is basically a voltage divider using two resistors, and one of the two resistors is the fan. And the Zener is just used to ensure that the second part of the circuit doesn't exceed 12 volts. So this is just a very simple feedback circuit that keeps the voltage constant. But if we change the internal resistance of the fan, for example, using a fan that doesn't consume as much, for example, a 0.07 amps fan, the one I got in my amplifier, the internal resistance is double. So let's assume the internal resistance of the new fan is 380 ohms. We can see that the voltage across the other resistance now is 8.9 volts, and this is way below the required voltage for the op-amps. It means that the op-amps will go in clipping mode. This is because in this stupid circuit design, the fan is just used to dissipate the extra current, and I've never seen, honestly, something like this in all the other amplifiers. In normal amplifiers, there are used linear regulators to create the 12 volts for the op amps, but in this amplifier, which is a very cheap amplifier with some poor quality construction, they used simply a fan as a voltage divider. So the solution for this is just add another resistor in parallel with the fan, or 360, and put it in parallel with the fan, and we can see that now the voltage that goes to the op amps is now reached 12.6 volts, which is fine. So yeah, this is something quite stupid that requires a stupid solution. Simply adding a resistor, yes. Another solution would be buy a fan within the specs, but honestly, I already have a working fan. I just need to add a resistor to mitigate the problem. This is a horrible design and I don't recommend this to anyone. And yes, we can see just from this design that they tried to save as much money as possible while building this amplifier. I mean, yes, after adding the resistor and trying everything, I've seen that the amplifier works. It's not as hi-fi as other amplifiers I've tried before. This circuit is very basic. It has protection for high temperature, for DC current at the output, but this system for powering the op amps is very basic. And keep in mind that a fan is not a fixed resistor. The internal resistance of a fan actually depends on the air resistance, depends on the speed of the fan. So using a fan as a resistor is a very bad idea. So for now, I will end the video here, and we'll see you guys next time.